Algebra 1, 13.3b, we're going to solve quadratic equations by completing the square when a equals 1. Now, it's really important that you watch videos 13.2b and 13.3a before you watch this one so you don't get lost or confused. And there's links in this video's description so you can just click on them and watch them real quick, okay? Because we're in 13.3b, and I don't want you to get lost or confused about something that we covered that you don't know about. So knowing how to use completing the square will help us write quadratic equations in standard form. So for x squared plus 10x, when this 10x is divided by 2, which is a 5, and we square it, that gives us our last term. Isn't that kind of neat? We can also use completing the square to solve quadratic equations, and I want you to remember the addition property of equality lets us add or subtract from each side of an equation and still have an equivalent equation. So if we want to isolate this x, we can add 4 to each side and get x equals 14. So we're going to do that for completing the square. And this is our quadratic equation, and if a is our buddy the invisible 1, and we only see x squared up in front there, see? When that leading coefficient a for x squared is a 1, we solve the quadratic equation differently for completing the square than if it were not equal to 1. So if it was larger than 1, we would do it differently, and we're going to do that in the next video. So you're going to want to watch that one too. This one is for when it does equal 1, okay? So this is when a does equal 1, our buddy the invisible 1. We're going to use the addition property, and we're going to unfoil. So our equation is x squared minus 4x minus 7 equals 0. We're going to move the 7 to the right side of the equal sign by using that addition property of equality. And we're going to create a 0 pair here, right? Now we've got x squared minus 4x equals 7. Now we're going to add 4 to each side of the equation. That's a perfect square, isn't it? So we're going to get x squared minus 4x plus 4 equals 11. See, 7 plus 4 is 11. Now we're going to unfoil, because now we added this 4, see? If it were a 16, we would have added a 16, see? So now we've got x minus 2 squared equals 11. And see, if we FOIL this again, x minus 2, it would be x minus 2 times x minus 2, wouldn't it? And then we would get x squared minus 2x minus 2x minus 4. And that would bring us back to this one, wouldn't it? So we're kind of unfoiling to get here, all right? Now what we do is we take this little 2 off, and we throw a radical sign onto the 11. That's the square root property. It says that we can flip either a 2 exponent on this side or a radical sign on that side. And we have x minus 2, because now the parentheses are gone and that little exponent's gone, is equal to a plus or minus square root of 11. So now the radical sign's on this side. Now to isolate this x, we add 2 to each side. Now we have x, see, this created a 0 pair. Now we have x is equal to 2 plus or minus the square root of 11. So our solutions are 2 plus square root of 11 or 2 minus square root of 11. See that? We can write it in a solution set like this. Okay? All right. If you're confused, you might need to go back and watch those 2 videos, okay? All right, so now here, a is still our buddy, the invisible 1. We don't have anything here. It's an invisible 1 in front of that x squared. Because of this minus 1, we're going to add 1 to each side. See, on this one, it had a minus 7, so we added 7 to each side to get rid of it. Now it's got a minus 1. We're going to add 1 to each side. If it said plus 1, we would subtract 1, okay? We're just trying to get rid of this value. We're trying to create a 0 pair here. So by doing that, we end up getting rid of this guy, and we get x squared plus 5x equals 1. Now, we're going to come down like we did over here. Remember in the beginning, we came down, we divided it by 2. We got the 5, we squared it, and we put it back up there. Okay, well, we're going to do that again, but over here. The 5 divided by 2 is 5 halves. We're going to square it, And that's 5 times 5 is 25 over 2 times 2 is 4. See, 25 over 4. But we're going to add it to both sides of the equation, all right? And we can do it as 4 over 4 because that's our denominator, plus 25 over 4. We get 29/4, okay? So that's what's going to be on that side of the equation. And now we look like this. And we're going to factor on the left and we're going to add on the right, okay, of the equal sign. We're going to factor on the left of the equal sign and we're going to add on the right of the equal sign, okay? So factoring, we get x plus 5/2 squared, and on the right, we add it and we get 29/4. Now we're going to use that square root property and solve for x. We're going to get rid of this little exponent 2, and square root property says if a squared equals b, we can take away that little 2 exponent and put the radical sign on the b. See? That was in video 11.1a if you want to find that one, okay? I'll put a link in this video's description for you if you're really confused and you want to see that one. So now we got rid of the parentheses in this little 2 exponent and we put the radical sign around the 29/4. See? Are there any perfect square roots inside of here? Is the 29? Nope. Is the 4? Yes. So we can rationalize the denominator as a 2 times 2, put the radical sign only on top of the 29, and put the 2 as a denominator by itself. And now we've got x plus 5/2 equals plus or minus the square root of 29 divided by 2. We need to isolate this x, so we're going to take away this 5/2 from each side. And now we've created a 0 pair here, haven't we? And it's gone. And we have x is equal to negative 5/2 plus the square root of 29 divided by 2. And x is equal to negative 5/2 minus the square root of 29 divided by 2. We can write it as a solution set like this. See? Because they both have 2 as the denominator, we can just make one big fraction bar and put the 2 underneath. And that's our solution set, plus or minus. All right? I know this can be very confusing. Maybe watching the video a second time will help you. But you need to really understand this before you go on to my next video because that one's even a little bit more difficult. You want to take notes and use these as templates so that when you come across a problem like this or a problem like this, you can look in your notes and say, that's how I solved that kind of problem. That's how I solved that kind of problem. And I'll just copy what was happening here to solve another one with different numbers in it, okay? That'll help you, all right? So, of course, like I mentioned, 13.3c, we're going to do completing the square to solve a quadratic equation, except now a is not going to equal 1. We're going to have a bigger coefficient in front of that x squared. Any of the previous videos or helpful videos I mentioned in this one is going to have a link in this video's description, all right? So, take lots of notes, watch the video again if you have to, and I'll see you next video. Bye.